this is kind of a thing showing that if you treating strong base, strong acid to that alcohol, we can expect double bonds forming in the multiple different positions. How that goes. This hydroxyl group is going to be protonated with a strong acid, right? Then you have a water sitting in the molecule as a leading groups. When the water goes out, you get the carbocation on the secondary positions. And then the lesson I gave you is that as soon as you see the carbocation, you've got to ask this question: will it rearrange? Right? So there is a hydrogen in the more substituted position that can move. But just to say that, if base come and pick up this hydrogen on that side to this initial carbocation, then you're going to make a double bonds there. This molecule is that product. So how that's products? These products in the middle is produced from the initial carbocation going through the ion elimination reactions. But we know this is not really the major. Major one is probably the secondary carbocation because the tertiary carbocation by making the hydrogen shift. Right? That will be the second, the most stable carbocation, tertiary carbocation. So I'm expecting this carbocation is more abundant than the initial carbocation because there's a tertiary carbocation. Once you make the hydrogen shift, now you can have a two different positions to lose a hydrogen. One from this on the ring, that this double bonds with the ring, and then the other, this hydrogen on the methyl groups goes, and you get double bonds in the between those two. So that is produced from less substituted hydrogens are lost by the base, and then you get double bonds here. More substituted hydrogen gone, then you get that product. So out of these three, which one is going to the major? Then you should consider the ones from the most abundant, most stable carbocation, and then the more substituted one, which is that one. That should be the major one. So this is just nothing but E1 elimination reactions. But the formation of the carbocation is basically kicking the water molecules out after protonating the alcohol. So this is basically what it is. Okay. So let me just make a few comments and we can get started here. Remember that SN1, E1 always competes together, right? I've been showing only the alkenes. Why not we having an SN1 product here? Well, let's say that you get this carbocation form and the water molecule comes attack that one, and then we're gonna get the substitution product, losing a proton like this. So what it is kind of very simple trick. Yes, SN1 can happen with an E1, but when SN1 happens, it basically goes back to starting material. So you don't see it because your starting material make the carbocation, as E1 make the double bonds. When it makes an SN1, this just go back to the starting material. You're not going to see it. So that's kind of a neat trick. That's why it only forms a double bond. It doesn't mean that SN1 doesn't happen. It happens, but it just makes the starting material back, but it looks like nothing has actually happened. So, and then that one just going through the process again. When the E1 product accumulates it, SN1 just go back and do it again. That's basically what it is.